Hi, welcome back to lecture 7. Now we're going to talk a bit more about CO2 levels in the atmosphere, sea level rise, and therefore how glaciers kind of impact all that. Here's a figure that I'm not a fan of because there's no source and I couldn't find the source of it. But basically what this figure represents is the fossil fuel emissions into the atmosphere for a long period of time. Really pay just attention here to the first part of this plot between 1850 and the 2000. That is an estimation or measurement of how our fossil fuel emissions have been basically steadily rising since the 1950s. And so you can think that if you put more CO2 in the atmosphere, the CO2 emissions or fossil fuel emissions, then you could expect more greenhouse gases in the atmosphere. And that was one of the focuses of the organisms working on climate change for a while. First, is global warming real? That was the first step. The second step was, is it due to human activity? And it turns out that yes, global warming is real, and yes, it is due to human activity. Now there's a consensus on that, and there are a few dissident voices that do not agree. But when you look at the arguments, it just doesn't make sense. So just brushing quick on that. But basically, what we have when we talk about fossil fuel emissions and CO2 level in the atmosphere, we usually refer to those things, the RCP levels. RCP means representative concentration pathways, and that's a way to describe the amount of greenhouse gases that we have in the atmosphere, the amount of greenhouse gases emissions. And those are the number after RCP shows kind of the intensity of those emissions. So RCP 2.6 is the most optimistic greenhouse emission scenario, where we say our greenhouse emissions are going to go down. And so we're going to try to limit the climate change, basically. And RCP 8.5 is the most pessimistic, or the one that actually follows our current trend. Is where we just don't throttle down on the fossil fuel emissions, and we continue as we do today. Another thing that's, maybe I'm just going to go to the other figure. So all these figures can come from the IPCC reports, the Intergovernmental Panel for Climate Change. So that's an international organization of hundreds, thousands of scientists from many different fields that all study the impacts of climate change and what awaits us in the future. And they come up with very useful figures, synthesis reports made for decision makers, but also the public, kind of explaining, breaking down all of that. Those are very intense reports. It's like thousands of pages, but eventually you have things that are pretty well detailed. APCC AR5 is the version. That's the 2014 IPCC report. I don't remember. That's one every few years for sure. We had AR6 not that long ago. And so this figure is from 2014 from IPCC AR5. And what it shows is that from 2014 and on after that, we have models depending on the RCP scenarios. So are we putting more greenhouse gases in the atmosphere or less greenhouse gases? And we have the level of CO2 in the atmosphere that is equivalent to the scenario that we are studying. And what we see is basically we don't know what's going to happen. It's going to depend a lot on our decision as society to limit our greenhouse gases emissions or just continue as we are doing today. And what you can see is actually for all of these reports, whenever we can measure precisely how greenhouse gases have been in the atmosphere prior to us, but when it comes to predicting how it's going to be, it goes all over the place because there are so many factors that impact the possible futures. So that's the role of this international panel, is to try and provide tools for people to understand the consequences of our actions and how we can limit threats and damages on the planet. So with high carbon emissions, high fossil fuel emissions, high carbon dioxide levels in the atmosphere, we can expect, as we saw during last lecture, higher air temperatures. So higher air temperatures means more melt for the glaciers, and more melt means higher sea level rise, more sea level rise. This map here from NOAA shows the sea level change between 1993 and 2021. And the color is, so the darker blue it is and the higher sea level has been rising, and the more white or brown it is and the more negative it has been, so actually the sea level going down. The first thing that we can show is that sea level rise does not happen evenly on the planet. It's not just one blood color, it has a lot of contrast. And actually, in some places, sea level rise is not rising, sea level is dropping. That's a very interesting concept that is just, it's a minority on the planet that in some places sea level is dropping, and that's due to very particular circumstances that we'll detail a bit later. But the important thing is that most of the planet is experiencing sea level rise, and the sad thing is it's mostly places without glaciers that are experiencing the most sea level rise. So that kind of highlights the fact that climate change is a rich person problem, in the sense that it has been mainly induced by rich countries. And yet rich countries are the ones who are right now paying the smallest price. It's really countries that are poorer, that struggle the most, that are actually the most impacted by those sea level rises. And even geographically, you can see, for example, in the US or in Alaska, where you have a lot of melt. And you take places like the coast of Africa, like Oceania, also on Japanese coast. But those places are the ones that are experiencing the most sea level rise, and therefore associated damages. There's a lot to talk about that. I could do an entire lecture, an entire course just on those issues. And this is what we project for the coming century. So again, we have precise measurement of how things have been so far, but whenever you want to project things for 100 years, it will depend a lot on the greenhouse gas emission scenario that you have. And here just plotted two different scenarios: the most optimistic RCP 2.6 in blue and the most pessimistic RCP 8.5 in red. And what we can see is the giant spread of possibilities. The washed out colors that are outside of the lines represent the uncertainty, meaning that, whoops, sorry. Here, that is the median value of sea level rise for RCP 8.5, but these are the range of possibilities of possible actual values in 2100. And even the most the most optimistic scenario shows a sea level rise of about 0.3 meters, so 30 centimeters. That's actually a lot. And one of the most pessimistic one shows a sea level rise of 1 meter by the end of the century. 1 meter probably doesn't sound that much to you, but it should. Go on the coast and try to imagine where the water would be if it was 1 meter higher, because that's not the only problem that it brings. It brings coastal erosion issues, weather pattern changes, and that is actually, as we do science, we learn more every day. And we learn more that our systems are unstable, like Western Antarctica. So those things, those scenarios are probably still optimistic, because there has been a constant in science and climate science, is that so far, whenever we were predicting some, for example, level of sea level rise, some level of sea level rise, some level of CO2 in the atmosphere, or some glacier melt, we've been underestimating it every time. Because in the 2000s, we were already doing those predictions, like how is it going to be in 2020? It turns out that in 2020, the reality has been worse than our predictions in most cases. So that is probably an optimistic projection of how things are going to be in 2100. Doesn't mean it's going to be the case, but it's more interesting to think of it as an optimistic projection rather than saying, oh, it's probably going to be all fine. Prep, the low-end carbon emission scenario, RCP 2.6, in which carbon emissions are increasingly reduced, shows negative annual carbon emissions by 2075. Do I show that in the, yeah, that's, oh, sorry. That's on this figure by 2075. You can see you are in the negative part of the plot. And so we're going to talk about that in the quiz. What does a negative annual carbon emission mean? I'm going to leave you a few seconds to try and answer that. I haven't talked about it, but you can try and answer that. What does negative annual carbon emission mean? Either that carbon emissions are reduced, carbon emissions have declined for many years in a row, that in a single year more carbon is removed from the atmosphere than released into it, or that all carbon emissions have stopped. The right answer for that is answer C. In a single year, more carbon is removed from the atmosphere than released into it. It's kind of like a mass balance problem in the sense that a negative annual carbon emission does not mean that we don't put any carbon in the atmosphere, but it means that we are taking out more carbon from the atmosphere than we are putting carbon in the atmosphere. Carbon emissions are reduced. It is true in a way, but that's not the most complete description of that. And also carbon emissions are reduced compared to previous year, which, you know, you could be, for example, here at that low point and you increase a bit more the next year, you are still negative, but compared to before, you are less negative, meaning that your emissions have actually increased a bit more compared to the previous year. That's just a detail. It's not answer B, carbon emissions have declined for many years in a row, because they could have declined and still be a positive annual carbon emission. And all carbon emissions have stopped. That would probably the same thing. It's kind of half of the answer. All carbon emissions have stopped, and let's say you don't remove any carbon from the atmosphere, then you would have a negative annual carbon. Sorry, you would have an annual carbon emission equal to 0, just like the mass balance problem. Imagine a glacier where you're not melting anything, you're not accumulating anything, then the net balance would be 0. So here, answer C. Negative annual carbon emission means that in a single year, more carbon is removed from the atmosphere than released into it. Positive annual carbon emission will mean that in a single year, more carbon is released into the atmosphere rather than removed. And neutral annual carbon emission would mean that in a single year, as much carbon is removed than put into the atmosphere.